Welcome everyone to the mechanics class. As you know, from last two classes, we are studying this subject, and we have started with the introduction and some basics of statics part. And in last session, we have studied friction as well. Okay. In today's session, we'll solve the problems. We'll solve only problems. So more of like there is not much theoretical part. All things will be problems, so we'll study only problems today. Combination of some difficult problems, some easy problems. Okay. And I want you to participate in it and solve it. Okay. Yeah, so let's start with some questions. Just a minute. Yeah, let's take some questions. The moment due to certain force F is 180 Newton meter clockwise. Okay. About origin, and 90 Newton meter counterclockwise. Okay. About B, as shown in the figure. If the moment due to force F about A is 0, the value of F is, okay, this is the question, and figure looks something like this. We have a point A here, we have a origin here, this is the x-axis, this is the y-axis. Okay, and B point is somewhere here. B is at around distance of 6 meter. Okay, and A is at a distance of around 3 meters. Okay, I hope with this information you will be able to solve it. Okay, go through the inputs, try to understand the question, and if possible try to, let's say, draw the figure here. Okay, how the force F will look like, actually where it will be in this figure. Then the problem will be very easy for you. What they have given is moment about origin is 180 Newton meter clockwise. Moment about point B is 90 Newton meter counterclockwise, and moment about E because of the force is 0. Can you tell me when the moment will be 0? Can you tell me what is the significance of this last input? Moment about A is 0. Yes, Abhishek, correct. Distance will be 0. Yeah. So in short, the force is passing through point A, right? If the force F is passing through point A, then only the moment because of force about A is 0. Do you agree? So use this as a hint and try to solve the problem. Okay. Force should pass through a point A because of this given input. That moment about A is 0. So this is a hint to you. And with this hint, try to solve the problem and tell me the first you should tell me the value of F. And this, let's call this as a question number A, and another I'll create one more here, and x-intercept. Okay. I also want you to calculate the x-intercept. X-intercept means the force F where it is cutting the x-axis. Anyone, at least the force F, have you calculated? See, moment because of the force. So we know that at least force A is passing through point A. We don't know in which direction this is. Okay. So assume that it is in any direction. But they have given few more inputs to us that moment about origin is clockwise and moment about point B is counterclockwise. So if I consider this figure, is it satisfying this criteria? No, right? This force will create counterclockwise about origin, also counterclockwise about B. We want clockwise about origin and counterclockwise about point B. And this is only possible when we have a force F passing through these 2 points. Correct. If it passing through these 2 points like this somewhere, then basically it will create a counterclockwise moment, or at least about this line. If it about this line at any angle, but that line should go or pass through O and B. Do you agree? Then only, let's say if I draw the force F here, it will create a counterclockwise moment about B and clockwise moment about origin. Are you following till this? Any doubt? Feel free to ask if you have any doubt. So now at least you got some idea that at certain angle theta we don't know, the force F is there, which is creating a zero moment about origin because it's passing, zero moment about A because it's passing through A. It is creating a clockwise moment of 180 Newton meter about origin and counterclockwise moment of 90 Newton meter about point B. Okay, so now let's try to solve the problem. What will be the components of this F? The horizontal component will be F cos of theta. The vertical component will be F sine of theta. Okay. This 180 Newton meter about origin will be because of the horizontal component only, right? So the F cos of theta, okay, or the horizontal component, let's call it as Fx, and this as Fy. So I can say it as Fx into 3 is equal to 180. Okay. And what is this 90? 90 Newton meter is created because of this vertical force Fy. So we should write it as Fy into 6. Okay. Then only we'll have the, so if this Fy force which is acting at 6 meters away from point B, creating a counterclockwise moment, right? So yeah, that's all. Then yes. Also, what they have given? Anything else? So use these inputs and try to solve the problem now. So if you subtract them, what you will get? Let's say fx into 3 minus fy into 6 is equal to minus 90. Okay. Let us assume that basically the moment about let's say no, let me explain you once again. Till this, I hope you all have understood that um, only the fx part is creating the moment, okay, about point origin, about origin, because the fy will be just passing through origin, so it will not create a moment. So fx into 3 will be equal to 180 degree, okay. And so fx you can calculate here itself. What will be the value? 60 Newton. Similarly, fy into fy, so at point B, not just fy, okay. At point B, not just fy, but also fx will create certain moment. So fy into 6, this is a counterclockwise moment, so I should write it as a minus, plus fx into 3 is a clockwise moment and is equal to minus 90. Let's call it as minus 90, okay, because it's a counterclockwise. So now you know the value of fx. Fx is 60. So if you put the value here, you will get the value of fy. So let me rewrite here. Minus 90 is equal to minus fy into 6 plus 60 into 3 is 180. Okay. So 180 minus 6 times fy is equal to minus 90. And if you calculate it, you will get fy is equal to 45 Newton. So you got the value of fx, you got the value of fy. So the value of f will be under root of fx square plus fy square. So it is under root of 60 square plus 45 square, and that is 75. Okay, so 75 Newton is the correct answer. Some of you have answered. Okay, we got question from Aman here. Explain, can you once again explain the direction of F? Okay. Aman, have you understood that the force should pass through point A? Is it clear till this? Yes. Okay. Then if you read the question again, what it is saying, the moment due to that force is 180 Newton meter clockwise. So in order to create a clockwise moment about origin, this force has to be on the right hand side of the vertical plane, right? This should be somewhere here, here, or here, right? Then only it will create a counterclockwise moment. Then only it will create a clockwise moment about origin. Do you agree till this? Now, one more sentence they have mentioned that 90 Newton meter counterclockwise moment about point B. So this force has to be on the, it should create a counterclockwise moment about B. Means the line of action of this force should be on the left side of the B. If it is on the right hand side of the B, what will happen? It will create a clockwise moment. Okay, that's why the line of action of the force F should pass through the line joining origin and B. Then only that force will create a clockwise moment about O and counterclockwise moment about B. Is it clear now? Yes. Okay. Now, look at the given. So what I did is I just randomly put F with a theta angle, and Fx and Fy are the horizontal and vertical component of that force. So Fx will create a moment about origin, which is causing 180 Newton meter. So from that I calculated the Fx, And about point B, moment will be created by both Fx as well as Fy. Okay, so moment because of Fx is Fx into 3, but the moment because of the Fy is minus Fy into 6 because it's a counterclockwise, so I am considering it as a negative. And what is this value? Its value is minus 90. So minus 90 is equal to minus 6 times Fy plus 3 times Fx, and the value of Fx is 60. So 60 into 3 is 180. And once you solve this, you'll get Fy is equal to 45 Newton. So under root of Fx square plus Fy square, that is under root of 60 square plus 45 square, gives you 75 Newton value. Okay. Now the next question: what is this x-intercept? So means they're asking this value. What is the value of x-intercept? So in order to get that, you should know the value of theta. Theta is equal to what? Theta is equal to tan inverse of Fy by Fx. Correct. So Fy is 40, Fx is 60. So I hope you should get it as 36.86. Okay. And now tan of now take any, let's say tan theta or anything, you will get the value of x. Okay, so if you know the theta, if you know this theta, you can calculate this value, and by using trigonometry you will get the value of x. Okay, the value of x should be 4. Yes, Abhishek, correct. Okay, any doubt till this? I hope it is clear to you all. Okay, if no doubt, then we will move towards the next question. Okay, simple, very simple question. 1 mark question. The moment because of or due to certain force P is P 500 Newton with respect to the origin as shown in figure. Is okay, you have to type the answer. So this is how the figure looks. Okay, this is the force, which is 500 Newton, and this is 5 meter. Yeah, and no, sorry, no, not this. Let's take it like this. Okay, this is another question I'll write here. It's okay, or Yeah, take this as 5. So find y-intercept. Okay. Yeah, very simple question. We got a force of 500 Newton, making an angle 45 degree with horizontal. What is the moment because of this force P with respect to origin? Quickly tell me the answer. Nothing to. Yes, correct. Abhishek, 1767 is the correct answer. Why? Because it will create two components, 500 sine of 45, 500 cos of 45. So moment because of the force P about origin is 500 sine of 45 into 5, and its value is 1767.76 Newton meter. And the next question is y-intercept. Very simple. Means where it will at the y-axis. That's yes, correct. It's minus 5. It will this distance basically will be minus 5. Okay, because this angle is 90, means this also has to be 45, right? And it means it's an um, these two sides are of same length. Okay, is it clear to everyone? Any doubt in this question? Feel free to ask. You can directly ask me or you can type your question. Okay, we got one question. Referring to the figure below, if F1 is equal to F2 is equal to 30 Newton, determine the angle. Angles theta and phi, so that the resultant force is directed along the positive x-axis and has a magnitude okay is 20 Newton will be okay. Figure looks something like this. This is the coordinate axis x and y. Okay, you got one force here, theta phi 30 Newton, 30 Newton. Okay, um, I'll not give options to you. You should try to solve it directly. So I'll repeat to help you understand. Determine the angles theta and phi so that the resultant force is directed along the positive x-axis. Okay, so what they are saying is the resultant of this magnitude of it is 20 Newton. Okay, this is the given data. So I think 70 point, yeah, close to 70.5 degrees is the correct answer. Correct, Abhishek. If you look into the question, 30 Newton is the force, right? Both are same, right? Because if forces are same and a resultant is along the diagonal, sorry, along the x-axis, it means their angles has to be same because of the symmetry in this figure, right? If these two numbers are different, then there is a chance that angles will be different. But now the numbers are same, means angles are also same. So if you take the component of this 30 Newton about the x-axis, so it will be 30 cos of theta plus 30 cos of phi, and that is equal to 20. But as I said, theta is equal to phi, so we can write it as 2 times 30 cos of theta equal to 20. So 30 cos of theta is equal to 10, cos of theta is equal to 1 by 3, and theta is equal to 70.5, I guess, around. Okay, just check 70 point something. Okay, and yeah, this is the final answer. Okay, and phi is also equal to theta. Any doubt in this question? Is it clear to you all? Are you following me? If you don't comment or ask, I'll assume that things are clear to you. Okay. If you have any question, feel free to ask. Let's take another question. Okay. So we got one question from Sham. If it is not equal, then how? Then in that case, Sham, they will have to give you one more condition. Okay, because whenever we want two different unknowns, we need at least two different equations, right? Then only we'll have we can calculate two unknowns. With single equation, we cannot solve, um, we cannot get the value of x and y. There can be multiple possibilities in that case, infinite number of solutions. So in that case, they will give you one more hint. Okay, maybe they will say, they'll give the relationship between theta and phi. Let's say theta is equal to 2 times phi, or 0.8 times phi, something like that. Some relationship they'll give in between theta and phi. Then you can use that relation and use the same logic here. Are you following? A 300 Newton box is held at rest on a smooth inclined surface by a force P, making an angle 30 degree with the inclination. Sorry, 45 degree with the as shown in the figure. Okay, the value of P is, okay, so let me draw the figure. So this is 30, and we got one box here of 300 Newton, and let's say, yeah, and with respect to this we are applying force at 45 degrees. This is a P force. Okay, and this angle is 45. Okay, this is the input to you. Okay, solve it. It is given to you, Sonali. 30 degrees is given to you. 30 degree is the inclination, and 45 degree is the force, which is the angle of the force with respect to the inclination. Okay, the main forces are like this P and the weight of the block. So if you solve this, yes, 212.13 is the correct answer. If this is 30, this has to be 30. Why? Because if angle between two lines is 30 degree, angle between their perpendiculars also 30 degree. Okay. Use another pen. This is also 30. So this is W cos of 30. And this is W sine of 30. Okay. Then this P will also create two components. P sine of 45 and one component here P cos of 45. Okay. And what we are saying here is the box is held at rest. Okay, means it is in equilibrium. So summation of all horizontal forces and summation of all vertical forces has to be equal. Okay, so summation of all horizontal forces is 0. So summation of all horizontal forces means what? P cos of 45 is equal to W sine of 30. Okay, so P value we have to calculate, and W value is what? 300. 300 sine of 30. Okay, so that's all. So sine 30 is 1 by 2. So P cos of 45 is equal to 150. So you'll get the value of P. Okay, can I move towards next slide? Is it clear? Okay, let's take another question. We are starting with simple questions. Okay, later on I'll bring little more complexity to it. So B may be of length 5 meter is supported as shown in the figure, and subjected to the forces at its two ends E and B. The reactions at the support C and D respectively are okay. So they have given a beam A, B, okay, and the length of the beam is 5 meter, supported at both the ends. Okay, 600 Newton, 600 Newton. Okay, and subjected to the forces. Okay, so these are the forces. Okay, these are not support. We have some supports at point C and D. Okay, I'll repeat the question. We got a beam AB of 5 meter length is supported as shown in the figure. C and D are the support points and subjected to the forces at the ends. So at point A and B, these are the ends of this beam, and we can clearly see 600 Newton is upward force at A, 600 Newton is downward force at B. The reaction at support C and D are, okay, we are supposed to calculate the reactions at C and D. Okay, S1 and S2. S1 and S2 are the supports, first and second. Anyone? Yes, distance between C and D is 3 meter. Distance between C and D is 3 meter. See, if you consider the reactions like this, what will happen? Okay, and apply the equations of the equilibrium, what we'll get is summation of all vertical forces has to be 0, right? Yes, Abhishek, correct answer. So 600 plus reaction at C plus reaction at D minus 600 is equal to 0 as per the equation of equilibrium. So what does it means? RC has to be equal to RD. Okay, the reaction at C and reaction at D has to be equal, but the direction, sorry, but you can clearly see RC is equal to minus RD. Okay, not let's say uh, plus RD. So what should be the value of or what should be the direction of them? Is it correct if I let's say write it like this? Is it correct? Yes or no? No, it is incorrect because in this case it will be unbalanced, right? So it both of them will create a clockwise couple. So it is in equilibrium. So the correct figure should be like this. Okay. So in short, the couple created, clockwise couple created by A and B, okay, should be equal to the counterclockwise couple created by C and D. Then only this is in equilibrium. Do you agree? So what is clockwise couple created by forces at point A and B? 600 into 5, and it is equal to the counterclockwise couple created by the reactions at C and D is um, RC into 300 or RD into 300, you can say. Okay, and hence RC is equal to, okay, so means the reaction, let's call it as general R, that is 1000. Okay, and RC is downward and RD is upward. Okay, so RC is 1000 downward and RD is 1000 upward. Okay, so the correct answer is 1000. You should directly type 1000 if it is question comes without option. If question comes with option, you can choose accordingly. Okay, any doubt in this question? Is it clear to you all? It's okay, let's solve some more questions related to beam quickly. All these are previous year questions. Okay, 1 mark, mainly 1 mark. Simply supported beam shown in the figure is supported by two supports, E and B, comma. Forces are applied as shown in the figure. Determine the reactions at the supports. Okay, so use this input data and figure and try to solve the question quickly. Tell me the value of RA and RB. A simply supported beam shown in the figure is supported by two supports A and B. Okay, and forces are applied as shown in the figure. Distances are also given to you. I don't think this is difficult problem. Apply the equations of the equilibrium. Summation of all vertical forces has to be equal to 0, right? So RA plus RB is equal to 300. 300 means 100 plus 200. Write it as equation number 1. Horizontal forces are not there, so you no need to use that equation of equilibrium. As the force system here is coplanar non-concurrent, you can also apply moment equations. Okay, so if you take moment about point A, for example, moment about point A is 0, so 100 into 1, that is creating a counterclockwise moment, right, about point A, plus 200 into 1.5 is a clockwise moment, and that is equal to reaction at point B into 3. Okay, which is creating 100 into 1 is negative, because it's counterclockwise. Okay, and then you can even write it like this: minus RB into 3 equal to 0. Okay, This is clockwise, this is counterclockwise. So I'm considering counterclockwise as negative, clockwise as positive. So from this equation, you will get the value of RB. RB is 233.3. If you put this value in this first equation, you'll get the value of RA, that is 66.67. I hope it is clear. Okay. One more simple question. Okay. The question here is determine the um, okay, determine the moment because of force F, okay, about origin. Okay, this is the question. Okay. Okay, 200 into okay, you are talking about the previous question, Kanishk. Okay, let's first finish this question and then I'll come to you. Okay, let's solve this first question. So here the question is moment because of the force F about the origin. Okay, that force is making an angle 30° with the horizontal, which is at a distance 2 meters from the origin towards x-axis and 6 meters from the origin towards y-axis. Fast, can you tell me the answer? Yes, 840 is the correct answer. See, the component of F about the horizontal axis is 200 cos of 30, and we have here 200 sin of 30. Okay, so the moment because of this about origin is 200 cos of 30 into 6, creating a clockwise moment, minus 200 sin 30 into 6. Okay, yeah, so let's solve it. Yeah, you should get it 40 Newton meter. I hope it's clear to you all. Okay, can I move towards next slide? Any doubt in this question? Okay, sorry, it's mistakenly written as 6. 2. Is it correct? Yes, right. Thanks, Sonali. 200 sine 200 cos of 30. It the perpendicular distance for that is 6, and for this force perpendicular distance is 2. Yeah, I hope it's clear now. Okay, I'll come to the previous question to answer your doubt, Kanishk. Yeah. Mm, 200 into 2.5. Kanish, we are taking moment about point A. Okay. So if you consider point A, the distance from the 200 is 1.5 meter. Okay. Is it clear? So that is the reason I am taking 1.5. Okay. Any doubt in these two questions? Is it clear to you all? Okay. Okay. One more question. Okay, we got one question from Harsh. 200 cos of 30 would be negative, creating clockwise. No, Harsh. 200 cos of 30 about origin it will create clockwise. You are right, but clockwise is positive, right? If you consider clockwise as positive, 200 sin 30 will create a counterclockwise, and that has to be negative, right? So one should be positive and one should be negative. Is it clear? Okay. Yes. Yeah. The last answer will be 840 if you consider. See, if you make this as a negative and you make this as a positive, you'll get minus 840. But your assumption of minus in that case is minus means clockwise, right? So whatever the option you see, if they are asking you the number, directly type 840. If they're asking, if the options are given, let's say 840 clockwise, 840 counterclockwise, then in that case you should wisely choose the correct option. Okay, I hope you are following. So here my assumption is positive means clockwise. In all questions I am considering positive means clockwise. So 840 Newton meter I am getting answer. So I'm sure that this 840 is total moment about origin is clockwise. If it is negative, then I would say it is creating a counterclockwise moment. I hope is it clear to you, Sanjeev? Yes. Okay. Let's take a question. This little bit big question. I'll not write completely. I'll read it and you try to write it. Just the main points. No need to write all the things. Okay. A block of weight 981 Newton is resting on a surface. Okay, is resting on the surface as shown in the figure. The coefficient of friction between the block and horizontal surface is 0.2. Okay. The vertical cable is attached to the block, provides a partial support as shown in the figure. Okay. So we got a cable. Okay. This cable is attached to the block vertically as shown in the figure in order to provide the partial support. A man is pulling the block horizontally with a force of 100 Newton. Okay. What will be the tension? What will be the in Newton in the cable if man is just able to towards right. Okay, I'll repeat the question. Listen carefully. So we have a block weighing 981 Newton resting on a surface. The coefficient of friction between the block and the horizontal surface is zero point 0.2. We have attached a vertical cable, okay, which is providing a partial support as shown in the figure. And a man is pulling the block horizontally with a force of 100 Newton as shown in this figure. Okay, what will be the tension in the Newton in the cable if the man is just able to move the block towards right? Is this question clear to you all? Yeah. Okay. So what is the benefit of this cable? Cable is providing partial support. Okay. If cable is not there, then what will happen? We have to apply more force in order to move the block. And what is its value? It's clear cut. The value will be mu into n, right? Uh, because the friction force will be mu into n. So 981 into um, so assume that you don't have cable for the time being. Just to explain you this concept in more detail. Okay, assume that you don't have the cable here, so only we have one force acting towards right hand side in order to move the block. So can, in that case, will that be 100 Newton or more than that? Okay, this is a force F. 981 is the weight, and this is again 981, and mu n will be 0.2 into 981. So the value of F will in that case is 196 something. Okay, 196 Newton close to. So you can imagine if it is, let's say, a block without this cable, we need 196 Newton force. But in 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 this we are attaching a cable, and that is helping us to give partial support. So we don't need 196. You don't have to apply 196 Newton force in order to move the blocks towards right. 100 Newton force is sufficient. Okay. So given that, you have to calculate the tension in the cable. No, Sonali, it is not given 196. I am helping you to understand um, what is the benefit of the cable here. Okay, what cable is adding the value. Okay, see, if you don't have cable, then this is the situation. In order to move the block, you have to apply force more than 196. But in our question, 100 Newton force is just sufficient to move the block because of the partial support provided by the cable. So this is just to help you understand the question and calculate the value of tension in the string. Yes, Abhishek, your answer is correct. 481 is the correct answer. If you draw the free body diagram, we got tension, we got let's say normal reaction in upward direction, and we got 981 Newton weight in the downward direction. We got 100 Newton force in the rightward direction, and we got a frictional force F in the left direction. Okay, so let me write the. Okay, Sham is asking how tension is helping to move right. Okay, uh, Sham, if block is of 981 Newton weight, its normal reaction will also be 981 Newton. Do you agree? So if 981 is normal reaction, in that case the frictional force will be 0.2 into 981. Is it correct? And the value of this is what? 0.2 into 981 is 196. So it means you need at least 196 Newton force in order to move the block towards right if string is not there, but or the cable is not there. But if now we are attaching a cable to the block, and they are saying that you the 100 Newton force is just sufficient to move the block because the cable is lifting the block slightly upward. Because of that, what will happen is frictional force in between surface and the block will reduce. Okay, is it correct? Are you following? Let me explain you when I calculate the value of frictional force in this case. Or so what is the value of n? Or if you do the summation of all vertical forces equal to 0, T plus n equal to 981 Newton, right? And what is the value of n here? Normal reaction. It is not 981. It is 981 minus tension in the string. This is the difference. Here value of n is what? Normal reaction was 981. Here it is 981 minus tension. So as you increase the tension, the normal reaction will go on reducing. So that's how the cable is helping us to move the block easily towards right. Okay. And what is the frictional force? Frictional force has to be equal to 100 Newton because summation of all horizontal forces is equal to 0. So frictional force is equal to 100, and that is equal to mu into n. Mu into n. So 100 will be equal to 0.2 into n is 981 minus t. That's all. So calculate the value of t. 481 Newton you will get. Is that clear to you all? Any doubt in this question? Hardly one or two people are able to solve this question. And I didn't see the answer from others. I assume you also getting what I'm trying to explain here and able to solve this. If you have any doubt, feel free to comment. Okay. Okay, no problem, Sonali. It's good that you understood it. If similar question you get in future, you know how to deal with it, right? So no need to worry. Let me give you some more questions. A little bit difficult. I try to think on it. Okay, just for your understanding. A block of weight W1 equal to 200 Newton rests on a horizontal surface and supports supports on top of it another block weight W2 is equal to 50 Newton. Okay. as shown in the figure. Okay, so let me explain you the figure. We have one block, and we have one more block. W1 is equal to 200 Newton. W2 is equal to 50 Newton. Okay. The block W2 is attached to a vertical wall. Attached to a vertical wall by inclined thread AB. Okay. The magnitude of horizontal force. So the magnitude of the horizontal force applied to the lower block as shown in the figure. Okay, that will be necessary to cause slipping is okay. So basically, this is the P force they are talking about, of which you are supposed to calculate the value. Okay, and what another thing they have mentioned is the block WT is attached to a vertical wall by an inclined thread AB. So let me just show you how that, like this, something like this thread. We have AB thread. 3 Newton block, and the slope is given to you. This is 3 and this is 4. Okay, is this question clear to you? I'll repeat. A block of weight W1, that is 200 Newton, is resting on a horizontal surface and also supports on top of it the another block which is of 50 Newton as shown in this figure. And here a block W2 50 Newton is attached to a vertical wall by an inclined thread AB. Okay, which is making this slope with respect to horizontal. The magnitude of the horizontal force P, okay, applied on the lower block as shown in this figure, that will be necessary to cause the slipping is. Okay, I'll give you 2 minutes of time. Think on it carefully and solve it. slipping means Shrujana, moving. Okay, let's say a block A, the first block is moving with respect to other. Okay, uh, so slip means there will be a motion in between these two blocks. No, 230 is not correct, Abhishek. Mu is the coefficient of friction. Okay, the value of mu you are asking. Oh, I have not given it. Okay, then mu is 0.3. Mu is 0.3. Okay, consider mu as 0.3. Okay, let's solve this question. Mu is 0.3 between all contacting surfaces. Okay, so let's solve this question. First of all, the angle theta you should know. Let's try to draw the free-body diagram of block 1 and sorry, the block with a 50 Newton weight. If you try to draw that free-body diagram, you will realize that you will have 150 Newton force downward. You have one, let's say, normal reaction upward. This is W2, right? Because it's a second block, and we have one string in this direction, it which is making an theta degree with the horizontal. So the horizontal component of that tension will be Tx and vertical will be Ty. And this theta you can calculate. Tan of theta is equal to 3/4. So theta is equal to tan inverse of 3/4, and that is 36.86 something you'll get. Okay. Now, so directly I will write the components, not the T, so you will understand it in clearly. So this is T sine of 36.86. Okay, the component of tension in the vertical direction. The tension component in horizontal direction is T cos of 36.86. Okay. See, because of this force P, the block will move in, was able to move towards right. So the frictional force on this block in this direction. Do you agree? In the block of weight W1. But on the block B, which is of our second block, which is of weight W2, which is equal to 50 Newton, frictional force will be in this direction. Okay, because W1 and W2 are connected. So in that case, the frictional force is in right hand side direction. So here, the frictional force I should write towards right hand side, and that is, let's call it as F2. F2 is a frictional force between the blocks W1 and W2. Okay, is the free body diagram clear to you all for the block number 2? Any doubt in this? Okay, it is clear? Then very good. You can do the summation of all vertical forces equal to 0, summation of all horizontal forces equal to 0, because of equations of equilibrium. You'll get some things there. So summation of y, summation of all vertical forces equal to 0. So what we have in vertical N2, we have W2 plus the component of tension in the vertical direction. So T sine of 36.86 is equal to 0. And what is the value of W2? Or let me just first write it as in general, so things will be clear to you. Is equal to 0. N2 okay, N2 minus W2 is 50. Ty is T sine of 36.86, so it is 0.6 times T is equal to 0. So from this you will get a relationship. Okay, or let's keep it as it is for the time being. Call it as equation number 1. Okay, we got a question from Harsh. The friction again. Okay, so I'll repeat, Harsh. So this is one block, and this is another block we are keeping on it. Okay, you are able to move this block, and this is your surface. Okay, if you are able to move this block in the horizontal direction, so the frictional force on the block will be in this direction. Do you agree? Now focus on these two blocks. Forget about this. This block is moving in the right hand side direction now. So what will be the frictional force on this block? See, on this block it is in this direction, but on this block, see, slip is occurring means this block, the block which is on downward side is moving in right hand side direction, and the upward block is left hand side direction, right? So in order to have balance, like your frictional force here is in this direction. Okay, so the magnitude will be same, just the direction will change depending on which free body diagram you are considering. Yep. So let's continue. Summation of all horizontal forces equal to 0. Tx is equal to F2. Okay, Tx is equal to F2. And now what is it? Tx? Tx is T cos of 36.86. So 0.8 times T is equal to F2. And what is F2? F2 is mu times N, and the N we already got. So N2 is what? N2 is 50. Sorry, this is plus minus 0.60, right? So F2 is 0.3 into 50 minus 0.60. Okay, 50 minus 0.60 Newton. 0.80 is equal to 0.3. into 50 minus 0.6 times T. So if you solve this, you will get the value of tension, 15.3 Newton. And if you put into this equation, you will get the value of N2, and that is 40.8 Newton. And if you know the N2, you will get the F2 as well. So that is 0.3 into N2, and that is 12.24 Newton. Okay, is it clear to you all? So if it is clear, now we can proceed towards the free body diagram of the bigger block, which is 200 Newton weight. Here you will have a normal reaction N1. Also, the weight of the block which is kept on this will create again one reaction. Let's call it as N2. Okay, N2. We have one force which is horizontal, that is P. Because of this, we have F1 force. With respect to surface, we have frictional force F1 in this direction, and friction in between the blocks will be F2, and in this case it will be in this direction. Okay, so this is the free body diagram of the block which is at bottom, or the bigger block. So from this we got the value of F2. We don't know the value of F1 here. You know the value of N2, that is 40.8 Newton. You can calculate value of N1 from this. Okay, so here if you apply summation of all vertical forces equal to 0, N1 you will get as 200 plus N2, so that is 240.8. So if N1 is 240.8, F1 is 240.8, and that is equal to 72.24. So you got the value of F1, you got the value of F2. So if you apply summation of all horizontal forces equal to 0, this will give you as P is equal to F1 plus F2. The value of F1 is 72.24, value of F2 is 12.24, so it is 84.48. Okay, so little bit complex question, but this will give you a different type of problem that you should how you should deal with whenever two bodies are kept one over the other, how the friction force you can consider. Okay, Shrujana, I will explain the second part once again. Listen carefully. So this is the first block, or the bigger block, which is kept at the bottom surface, right? So I'm talking about this. The weight of the block is 200 Newton acting downward, and the normal reaction because of this support at the ground will be upward. So let's call it as N1. But we are putting one more block on top of this, that is 50 Newton, and that will create one reaction, right? That will also create one reaction, downward reaction. Okay, and that is N1. Why it will not create full 50 Newton? Because it is attached to string, so it will not be, let's say, fully 50 Newton applied on this block W1. So some part of it will come to here because of the string. If string is not there, in that case whole 50 Newton force will be, or whole 50 Newton reaction will be applied by the block B on block A. Okay, I hope it is clear. So that is the reason N1 sorry, N2 is 40.8, which is the reaction of the smaller block on this bigger block. and this N1 is a reaction because of the ground on the bigger block. Okay, so I hope you understood 200 Newton, N1 and N2 direction. P is also given to you, already given in the figure. So if block is moving in the outward direction, the frictional forces will be in the leftward direction, and that's why F1 and F2 are in the opposite direction to it. Shrujana, is it clear to you? It's okay. So from the first calculation, we got the value of F2, and here we are calculating F1 and just adding them to get the value of P. I hope it is clear to you all. Little bit difficult, but if conceptually it is clear to you, then uh, you may not be able to face any issues in future. Any doubt, feel free to ask. Okay, can I move towards next slide? Yeah, a little bit theory part I'll explain here. Belt friction, I have explained all friction part, but just this small part is remain. So suppose you have a pulley, and let's say a belt is wrapped from this pulley like this, and T1 and T2. How to find the T1 and T2? T1 is, let's say, high tension side, and low tension. High tension, if this pulley is rotating in counterclockwise direction, the arrow indicates the high tension side. Okay, if it is rotating in clockwise direction, then arrow will indicate the high tension side. So whichever direction it rotates, that side is higher. Okay, so assume here it is rotating in counterclockwise direction, so T1 is high tension side and T2 is low tension side. So the T2 by T1, you know this relation. That is what I'm trying to explain here. How the ratio of T1 and T2 is related to each other. Tension on the low tension side divided by the tension on the high tension side is equal to e to the power mu times beta, where T2 and T1 you already know. The value of mu is coefficient of friction between the belt and the pulley. Okay, mu is the friction, coefficient of friction, and beta is angle of contact. Let's call it as a beta, angle of contact, or you can also call it as a lap angle. Okay, in radian. So in this question, what is the angle of contact? It is complete 180 degree, right? So this is the total angle of contact. Are you following? So entire 180 degree, this belt is in contact with the pulley. So that's why in this case, I will say pi is the angle of contact for this figure. But if you get this kind of figure for okay, in this case you may have lesser contact, let's say maybe 90 degree or so. Okay, is it clear? Is it clear this part? T2 by T1 is equal to e to the power mu beta. Yeah. Let's solve one question. Simple questions. We'll start. 1000 Newton block kept on a horizontal surface, and it is attached to another block of weight P, for example. Uh, just a minute, not 1000. Let's keep it as 300. This question, a little bit I'll modify. Yeah. Can you calculate the value of P here? Consider the coefficient of friction is 0.3. Lap angle is 90 degree. Okay. And find the value of P. The coefficient of friction is 0.3 for all contacting surfaces. Direction of motion, Srijana, obviously we are not applying any force to the horizontal block in the left hand side direction, right? So if P is able to just move the block of 300 Newton meter, means because of the gravity towards right. So this is coming down and this is going in the right hand side. So basically it is rotating like this. Friction, coefficient of friction is in between all contacting surfaces, not only just pulley but also the surface. Okay, all contacting surfaces means you should consider everything, ground as well. Okay, so let's draw the freeboard diagram of both the blocks. First block, 300 Newton. It will have a normal reaction. We got a tension T1. Okay, or let's call it as a T2 here because it's moving. This has to be T2, T1 here, and T2 will be on this. And this is the frictional force. Another freeboard diagram of this P block. Very simple. P is downward force and T1 will be upward force. Yeah. And one more relation, T2 by T1. Okay, let me just help you with this. T2 by T1 is equal to e to the power mu beta if T2 is greater than T1. Okay, and you can write it as T1 by T2 is equal to e to the power mu beta if the T1 is greater than T2. So whatever you are assuming on that basis, it will change. So let me just write it in a different way to make you understand here. So T1 is this, for example. This is the first diagram and this is the second, for example. Okay, and you are calling it as a T1 and this as a T2. You don't know, forget about like T1 is, let's say, max tension and T2 has less tension. You think you just focus on the direction, in which direction the pulley is rotating. Pulley is rotating in this direction as shown, right? It means the tension on the side where arrow is there, it is a high tension side. So T2 is greater than T1 in this case. So you should use the relationship as T2 by T1 is equal to e to the power mu beta. So it is e to the power mu is 0.3, beta is pi by 2. So you'll get a relationship between T2 and T1 as T2 is equal to Mm, okay, let's keep it as it is for now, for the time being. Let's get one more relationship in between them. So here N is also equal to 300 Newton. What is frictional force? Frictional force is equal to 0.3 into 300, which is equal to 90. It has to be equal to 1, right? So if you put this T1 is equal to 90. In this, you will get T2 as 90 into e to the power 0.3 into pi by 2. And you will get T2 as 144 Newton. Is it clear to you all? Any doubt? Abhishek, 56.25 is for what? I think it's incorrect. If you're talking about T1 and T2, 144 is the correct for T2. T1 is 90. Others, do you have any doubt?
Sir, excuse me, sir.
Yes. Yes.
Sir, can I consider by two also?
Uh,
Like,
could you please repeat? Your voice is cutting.
yeah, sir, can I consider equal to e to the power mu b? Can I consider T1 by T2 also?
You can
Directly both.
consider. Yeah. Let me just show you. In that case, your figure will change. Okay. So the free body diagram for this. So you, okay, this is your figure. Then let's say this is your weight acting downward. This is the normal reaction. And you want to consider it as T2, right? You can consider. And this is the frictional force. And this is the block, another of weight P. And in this case, this is T1. You can consider, you can use the formula T1 by T2 because the formula is max tension divided by min tension. Okay, is equal to e to the power mu beta. Okay, you can still consider it. You will get the same answer. Okay. Yeah, we got a
Excuse
question
me, sir.
from Raj. Yes.
Excuse me, sir.
Yes.
Here we don't know the which is maximum, no, sir. Then how?
Yeah, we know. We know. The direction of this is in this direction. I told you, right? The direction I have given you. The arrow indicates the max tension side.
But
Okay.
if it's not moving, then sir,
If it is not moving,
just
then
like stationary.
yeah, in that case also, what is happening is, let's say, um, let me give you another example here. Okay, I'll add one more difficulty to it. Okay, I'll add one more force here in the next question to make it uh, understandable to you. Okay, here in this question, the P is about to, let's say, move the block in the rightward direction. But even if it is not, see, is there any other force? Do you agree this P is trying to pull this even if you don't apply the force, right? So if it is applying that force, um, means that will be the tension side because let's say this entire system will is trying to move towards right hand side, and that is why this is a high tension side. Okay, always try to draw the arrow to the direction of motion, and the arrow indicates the high tension side. Okay. Yes, we got one question from Sham. How the tension differs in the same string? Yes, Sham, the tension is different in the same string because of the friction. Okay, if you don't have the friction, the value of mu is 0, then T1 will be equal to T2. Okay, so if you consider the frictionless pulley, you are right that in the same string you will have no difference in the string. Okay, no difference in the tension, but it is a pulley with a friction, and that is causing the difference in the tension in the same string. Are you following?
Excuse me, sir.
Yes. Yes.
Uh, question.
Yes. Yes. You can ask.
Uh, so the question, sir. The slide na बोल रहा. Sir, sir, question slide.
Okay. Okay. Hmm?
Sir, in this question, sir, you have assumed P is greater than T1, sir.
No,
Sir,
I have not assumed
if I am
anything
assuming,
as such. Sorry, your
like, sir,
voice is
we don't know
breaking
the.
in between.
Hello?
Yes. Yes.
Sir, can you, if you assume like that, P is not moving, that like it's a stationary body,
Mhm.
then we don't know no, the in which part tension will be more and in which part tension will be less. We can consider two cases. In first
In
case,
that case
P will be great.
also, see, yeah, in that case also, see, if it is not moving, still there will be, let's say, tension in the string, right? And
Yes, sir.
you can clearly see, let's just because like system is, we are not applying any force in this direction, right? We are not trying to pull the block towards left hand side, so it is natural to have the natural motion in this case is possible is in the clockwise direction only. Block will never move. um, do you think of this kind of motion in any situation without force naturally? Is it
No,
natural
sir.
to have this motion? Then is it fine? So if it is not the case, then this side will never be a high tension side. Okay, always in the motion, like if you just put the direction of the motion in which you think that motion is possible in that direction, that arrow will always indicate you the high tension side. Okay, reverse motion is not possible practically without any application of force on the horizontal block. Okay, that is the reason I am considering here T1 as high tension side. Okay, yeah, or the this
Okay, sir.
P block as a high tension side. Ganesh, um, what is your question? I didn't understand. Low tension by high tension. You just mentioned that, but whatever the formula I have given to you, it is high tension by low tension. If T2 is greater than T1, this is the formula. If T1 is greater than T2, this is the formula. So the formula is for high tension by low tension. Okay. Don't consider, let's say, T1, T2 stuff. Just consider high tension by low tension is equal to e to the power mu beta, and just put give terms randomly. Okay. Any other doubt? Is it clear to you all? Okay. If no doubt, then we'll proceed. Same question. Try to solve it. Okay. This way. Okay. This is a 200 Newton block now, and let's say it has a 300 Newton block, and we are applying a force P here. Okay. The question is, what is force P? What value of force P is required to move the 300 Newton block from right to left? What should be the value of P to move the block from right to left? Yes, let me give you the value. Mu is equal to 0.3 for all contacting surfaces. Okay, things are little different now. Feel free to ask any doubt or yeah, beta is same as previous question, Sham, 90 degree. See, in this kind of conditions, generally it is 90 degree. Same question as previous. I just made that block of another block of 200 Newton and applied force P. No, 215, 230. No, incorrect. See, 200, 300 Newton downward. Upward is normal reaction. Right side is tension. We got a force P in this direction, and frictional force will be in this direction. Okay. So the value of N is 300 for the first free body diagram of the first block. Frictional force is 90. So P is equal to frictional force plus tension. Okay, this is moving in this direction. I'll call it as a T1. Okay. Now about the second block. 200 Newton is a downward force. So the upward force in this case is T2, and the value of T2 is also 200 Newton. And you know T1 by T2 is equal to e to the power mu beta. Yes, 410 is the correct answer. Most of you typing it. So from this we'll get the value of T1 as T2. Mu is 0.3 into pi by 2. 320.4 Newton. Okay, so if you put it here, to 20.4 plus frictional force, that is 90, that is 410.4 Newton. Okay, I hope it is clear. Feel free to ask if you have any doubt. See, Harsh, in question itself, it is given. Try to go through the question carefully. What is the value of force P to move the block from right to left? Okay, so move the block 300 Newton from right to left means the direction has to be like this, right? Are you following? If you want, I'll read the question again. In this figure, what is the value of the force P in order to move the 300 Newton block from right to left? Consider mu is equal to 0.3 for all contacting surfaces. Okay, no problem. So yeah, I hope everyone understood this question. Let me give you another question. Two books of 1 kg each are kept on a table. One over the another. The coefficient of friction on every contacting pair is 0.3. The lower book is pulled horizontal force P as shown in the figure. The value of F at which slip occurs between the two blue books is between the two books is. Okay, this is your homework question. You try to solve it whenever you have free time, and if you feel difficulty, I will help you to solve. Okay, so the question here is we got two books of 1 kg each, and we are applying force to the book which is kept at bottom. Okay, two books of 1 kg each are kept on a table, one over the another. The coefficient of friction contacting surfaces. The lower book is pulled with a horizontal force P as shown in the figure. The value of F at which slip occurs between the two books is. Okay. The final answer in this case is 8.83 Newton. You should get it. Okay. This is your homework question. You try to solve whenever you have free time. This is same as that of what we have solved before. Two blocks kept one over the other. Okay. So that's why I'm not solving it here. I want you to solve first. Try on your own and come back to me if you face difficulty. Okay. If majority of the people are not, let's say, getting it, we'll solve in the next session. But I don't think it's difficult for you as we have already solved a similar question before. Okay. If you have any doubt, feel free to reach out to me on WhatsApp. Okay. Everyone has written this question. Can I move towards next slide? Okay. I think one more question I'll give to homework because we are at the end of the session. A uniform bar AB, 10-meter long and weighing 280 Newton is hinged at B as shown in the figure. Hinged at B, one more sentence is there, and rests on a 400 Newton block as shown in the figure. Full stop. If the coefficient of the friction, if mu is equal to 0.4 at all contacting surfaces, the horizontal force P required to start moving the block is, block means the one which is 400 Newton block. Okay, figure looks like this. We have a block somewhere here kept on a surface, 400 Newton block. Okay, I'll repeat the question. Listen carefully. Um, here I'll give the answer. P is equal to 320 Newton. Okay, uniform bar AB of 10 meter long. So length of the block is 10 meter. Um, and weighing 280 Newton. Rest on hinged at point B as shown in the figure, and rest on a 400-meter block shown here. Mu is 0.4 for all contacting the surfaces. The horizontal force P required to start moving the block is. Okay. So if the question is just like this without this uniform bar, how much force P we need in order to move the block? It is 0.4 into 400. Okay, 160 Newton force is required in order to move the block if this uh, bar is not there. Okay, but we are putting a bar on it, so we are adding more restrictions or more opposing force for the moment of the 400 Newton block, right? So now with that condition, the load will be more than that is more than 160 should be the answer. So you have to calculate it, and you should be getting it as 320. Okay, so try this question whenever you have some free time, and if you face difficulty, we'll solve it in the next session. Okay, at least hope that this question you should solve without any difficulty, because similar question we have solved before. This question is also based on the same logic. Okay, one over the other, we have one block and another, or two objects placed one over the other. So here also you can use the same concept and get the answer. Okay, but if you finding it difficulty, I will be able to help you in the next session, or you can reach out to me. Okay, you can match your answers. I have already given you the answers. Okay, so that's all we have for today. Do you have any other doubt? Yeah, Madhu, you can just go through the previous year question papers or mock test papers or the booklet. I think that is more than enough for mechanics. You don't have to look for more than it. Okay, so you can just go through the booklet or previous year questions. That's more than enough. And here in class also we are solving many questions. So conceptually, if things are clear, and if you practice previous year papers, mock test papers, and solve booklet, then things will be clear. Okay, so that's all from my side. um, we got one question from Kanishk. Uniform rod will not be moving. No, it will not move. Okay, uh, the bar is, let's say, resting on the surface and hinged, and we are pushing it from the opposite side. So it will not, let's say, it is hinged at one end, so it will just rotate, but we are not interested in it. Our more interest is um, finding like force P. Okay, but P will not, definitely will not move. So you take, if you want to, let's say, understand it, you can practically take an example. Take a bar, hold it on a, let's say, in one hand on a, let's say, wall, and put its another end on a book and try to push the book. You will see that we are not applying any force, let's say, from left to right. Okay, if we are applying from force from, sorry, right to left in this direction, then the rod will move. Okay, in this case, as this figure, we are not having that kind of force, right? We are applying force from left to right, so that is the reason uniform rod will not move. uh, you you work on it, Sham. Okay, that is homework question for you. If I give all hints, then it is not, let's say, uh, you have to think on it, how to put the reactions and solve it. Okay, and you try at least for some time, and if you still find difficult, I will help you. Okay, I want you to spend time on it. Okay, so that's all we have for today. Thank you all for joining this session, and let's meet again in the next class. Bye, good night.